Hi guys, in this particular video what I'm going to do is I'm going to show you some conditional branching. There are two instructions in PIC16F877 which allow you to conditionally branch. Now conditional branches is slightly different from the unconditional branching which we saw before with the goto instruction, where whatever you have as the operand, you just go to that address. However, in the case of conditional branching, what happens is you have to make a decision, and based on some condition, you either go one place or another. So with BTFSC and BTFSS, as in we have right here on this line, what this stands for is bit test file register F. In this case, file register F is my operand port D. And skip, when it says skip, it means the next line. So that means we're either going to do this next line or we're going to skip it entirely and go on to this line instead, right? And we're going to skip if it is clear in this case. And if what is clear? If bit 0 in port D is clear, right? Similarly, I could have written that bit test register F, i.e. port D, and skip the next line if, in fact, bit 0 on in port D was set, right? All right. So the trick to dealing with this instruction, BTFSC or BTFSS, is to sit down and just write two gotos directly after the instruction. And depending on which way around you write it, you choose either S or C. So I wrote it down this way: either is 1, so that means the bit was 1, or is 0, that means the bit was 0. So if the bit was 1, what I want to do is I want to put FF into working register. If the bit is 0, I want to put 0 into working register. Yeah, and both cases I just go on here to done. Okay, all right. So the trick to writing this instruction is you write two gotos and then you decide after that whether or not you put an S or C there. Okay. All right. So let's see if I wrote this the right way around. So right now on port D, I have 0, 0 on the port, right? Now, if you notice my tris when we start up is actually FF, i.e. all inputs. So port D is all inputs right now. So I'm not bothering to change that in this case. I'm just going to step through this and take a look at what's going to happen, right? Because it's already an input. So I go to init, and since port D bit 0 is actually a 0, we're probably going to skip this next line and go here, right? Because we skip if it's clear, right? And that makes sense because we're going to skip this line when this is 0 and come to this line. And that's great. And that causes us to actually just branch there, go to done, and it's all great. Okay, I'm resetting. Now let's test it the other way around just to be sure. So what I'm going to do is I'm going to go in debugger, add a stimulus workbook. I guess I'll just put RD0 and maybe set high. I hit apply. Give it a sec. Come on. Takes a moment to figure it out. All right, good. So you see that little thing goes there. All right. So what I'm going to do is I'm going to hit this button here, which says fire. So notice the value in port D doesn't go high as yet, and that's because the value has been latched by the register. So what I'm going to do is I'm going to step. Okay, the value is latched, i.e. so the registered port D is high for the lowest bit. So therefore, we would think that it's not going to skip the line. It's going to just go to is 1. That line. So we go on, right? We don't skip the line. And we get to go to. And we're going to step again. And we get here. And we're putting FF in working register. And go to done. And that's all well and good. All right. So notice how I structured this. I went to is1, so I had an explicit go-to where I went here, right? Okay, so the first question is, if I had moved this line from here to here instead, would that have worked? Answer is probably not, because if the intent is to just load the working register, and we got the case of E1, it would have come and done this line, and then it would just go on and then put 0 in the working register and overwrite it. So the safer thing to do is just go with the two go-tos. Very often you can figure out after you've written out this nice long ways to optimize it, and that's true, that you can write it a bit shorter. For example, in the way I've written this, I could just take off this line, go to done, because done is right beneath here. I don't really need to have that line. And that's about it. So the trick is write it out using the two go-tos, write out your two statements, and then look to optimize after that. And after you have written on your go-tos, then you can figure out which way around you want to write the bit test, whether it's clear or set, up to you. Okay. Of course, you can also just swap the two go-to lines, but either way is fine. All right. Thanks for watching. Bye.